So we start with what we had done, the remaining part of the calculus problem. Okay. So if you remember, I said it was just rehash some of the earlier classes में आपने पढ़ा था what's ellipse, what's parabola, what's hyperbola, and there are some terms. So if I will have a broad thing, if you remember in conic section, it's basically a point traces. It's the loci of the point which is being traced by a point, and the ratio of the constant distance from a fixed point and this center. That ratio will determine whether the figure is ellipse, whether it's hyperbola, whether it's circle. And there are different, for example, equation of ellipse is this. Here, if you remember, b square is equal to a square, 1 minus square. And in case of ellipse, if you remember, we had this AE0, and there are two foci, and एक foci नहीं था हमारे पास, two foci. And the constant distance from which it's called dissectrix, that fixed line. And in दो focus के दरमियान the line which passes it's called lattice sector. Why just coordinates हैं, for example, coordinates of for example ellipse or foci का coordinates हैं this or So having this knowledge, so we are now using what? A particle is moving the central field, and the figure which is corresponding first, हमने लिया था वो total energy of the particles, and we parameterize the equation. If you remember, in the last class हमने किया था phi का value in terms of equations we got phi because we have to find phi. Phi is this equation. We have b plus m squared alpha squared b squared. This phi, and where this p was written in terms of m squared by n, and e का value of लिखा था eccentricity was took form of this. So we have solved this equation previously. इससे पहले हमारे पास दो इक्वेशन आई थी, एक phi के टर्म में आई थी, the other was in the form of t. When we solved the equation in terms of phi, it was phi basically we solved it. So this basic equation का हमारे पास आया था in terms of e. So now what we are doing? We are parameterizing E, the value of energy of E, in terms of this eccentricity. So eccentricity is dependent upon this value of E, energy. So that energy is total energy. Three terms are like so potential की term भी आ रही थी, and the other centrifugal term and this term, three terms. So this will determine what this value E is going to take. So what is the energy in a given field, which is in that central potential, bounded central potential, having a potential 1 by r square, 1 by r. So that will determine our eccentricity. And now we are going to take our knowledge of earlier classes of conics, the value of eccentricity. It can be less than 1, greater than 1, or 0, depending upon the figure. So in this case, it's ellipse. This is hyperbola, and this can be sorry, parabola also. So for parabola, what is the thing? For hyperbola, it's this. For parabola, it's what? Because we have to. Sorry. For parabola, it's fine. For parabola, it's 1. So we have taken all the four cases. So either it's less than 1, greater than 1. This is equal to first circle. So these are all trajectories along which we normally take point. So here we have replaced point by a particle, which is moving in a central field, having a potential 1 by r square and having energy E. And this value of energy, क्या आएगा, plus आएगा, minus आएगा, जो भी आएगा, whatever. Because if you, so it will give us the value of this and this. What the point? And you have to be also conscious of the fact in case of ellipse, we have two forces. Okay. And the particle, when it's, this is known as R minimum. When it's closer to that one force. And it is known as R maximum. When it's away from it, the other part of it. What the point? So the particle, if it's having this trajectory, we have to see it in terms of this and this. अब हमारे आपके अगले क्लास में wrote it this way. But there is also another way of writing the same thing, which this book has a follow. You might have followed this thing. So this is another way of writing the same thing is that if P is like this, P को हमने ऐसे लिखा, P को हमने ऐसे लिखा. So we can write equation of motion P by R is equal to 1 plus E cos phi. So this is the equation of ellipse hyperbola. We can also write it, this ratio of P by R, P को in terms of this and square by m alpha square. And P can say it's basically what? If you remember, P is this. P phi हमारे पास है angular momentum का coordinates in terms of okay. So this is P, this is eccentricity, and इसी equation को, these equations, for case of parabola it might be this. For circle it's x square, a square, a is equal to b is equal to 1, it's x square plus y square is equal to 1. For parabola it's y square is equal to 4ax. These are all four trajectories. So all four trajectories are possible in case of centrally particle which is having a bounded motion in the central force field. You got the point? And we are not going to write it this way. हम इसको in terms of we can also write these equations of ellipse in terms of this. And this all is the radius, which is the radius. अब ये रेडियस है, it can be R maximum as well as R minimum. So we are not writing the equation of ellipse in this way. We are writing it. We can also write it in terms of this. In terms of this. So if you write it in terms of like this, R is R radius. So R radius can be R maximum when it's closer to this first foci. Okay, so you can get apogee. And when it's at this distance, it's known as period. In your earlier classes, हम उसको B के साथ represent करते हैं. It's in terms of period. B is like this, B is like this. So if it is like that, if you write it like this, and now I just show you in terms of book, the main book has shown, So this is the lattice rectum. Lattice rectum, if you remember, it's basically the line which passes through one of the foci. There are two lattice rectums. एक pass करता है एक foci, the other will pass through another foci. ठीक है? And this is known as what? Dissection. If you remember. Okay. Dissected is the point which is the constant from the constant line. This is also known something exactly. So यहाँ से यहाँ तक so अब इसमें भी होते हैं there are two ये हो गया ये वाला there can be two radius 2a this is 2b दो radius एक तो horizontal है एक this is a plus a this is b plus b that's so you have to see the motion अब ये है कि the particle may be anything it may be an electron moving around a nucleus or it may be some planet moving around sun so its motion closer we are going to study in terms of these parameters x a b okay p is the this thing and p को हमने यहाँ से so least so for e जो मैंने कहा for का so for e less than 1 less than 0 well, if its e is less than 0 if e is less than 0 so it will be less than 1 है ना ये 1 minus कुछ आएगा so anything which is less than 1 essentially is less than 1 the figure will correspond to the ellipse ठीक है so from this value of eccentricity when it's related with the energy of the particle which is in turn related to the total energy of the particle which corresponds to three terms kinetic terms potential term kinetic में लिखते हैं Lagrangian of the system तो वो तीन terms आते हैं centrifugal term या फिर potential term आते हैं ये kinetic term so if it comes out to be less than 1 so essentially so the trajectory will be elliptical the trajectory will be elliptical or e less than will correspond to e less than 1 so according to formula for analytical geometry which I said yesterday also analytical geometry I said yesterday also formula for the analytical geometry. So A, the value of A will be P by 1 minus E square will be alpha by 2E. And this is value A. A is the one of the radius. This B is this radius. A radius is horizontal. B है radius vertical. So if you write A in terms of P and this, it will be this. You can check it out. आप इसको P को और substitute करो वहाँ पर, ठीक है? It will come out like this. And you basically substitute P के बदले आप लिखो this. You substitute P for this, and for E you substitute this. ठीक है? You will not do it अपनी जगह. So if you do these two substitutions, value of A after simplification will come out to be simple like this. The smaller radius, okay? Because we can go through the radius. So A can be written as alpha by. In the same way, B can be written as B can be written as B can be written as B by root of. So here, if you remember in the class, so this is x square plus b by a square minus y square by b square. This was the equation of ellipse. B square was e square by 1 minus b square. A square, I said. 1 minus e square, sorry. B was a square, 1 minus e square. अब यहाँ वही चीज हम कर रहे हैं. अब देखो यहाँ जो b है, this is b by root. यहाँ 1 minus e square है. So we are writing it like this. We are writing the same thing, but in this. Again, if E is equal to 0, if E is equal to 0, so this equation will become one item E by R. So it will become equation of circle. Just like आप कर रहे थे, आप देख रहे थे equation of ellipse में A is equal to B क्या आएगा? 1 आएगा बराबर, तो it will give us equation of circle. The same you can write in terms of this thing, that if the value of E is less than 1, now if the value of E is 0, if the value of E is 0, this will P by R in the first equation of circle. अब यहाँ ये एक पॉइंट है, पहला पॉइंट की सीरीज द बुक says that if the it will be noted that the major axis of the ellipse depends only on the energy of the point. Major axis जो है dependence है only energy, only on energy, and not on its angular moment. पर सोचो what does it mean? So major axis, major ये होगी minor axis. Major axis कौन सी? ये वाली? This one. तो ये क्या है? Major axis depends only on energy. कितनी energy है system? That includes kinetic and potential जो भी है, all the three terms, and not its angular momentum. So इस पर आप थोड़ा सा think of it. Think. So sometimes there can be some algebraic part of it. It's not clear. Okay, you just try to think about it. You want to see, है ना? Again, the least and the max, minimum radius and the maximum radius को हम अगर लिखेंगे, अब ये equation जो हमारे पास है, this equation. If you want to write, if you want to write, if you want to write this equation, so P by R, so we are writing this in terms of 1 by cos of phi. So this is इसमें सब equation of ellipse की है, equation of parabola भी है, hyperbola भी है. Circle is there, 1 plus E cos phi. Depending upon whether E is plus, minus, 0 or 1. The value of E can be 1, minus 1, 0 and greater than 1, sorry. Less than 1, greater than 1, equal to 1 or equal to 0. So less than 1 ellipse, ये hyperbola आएगा, ये parabola आएगा, and ये circle. ठीक है? So अब ये इसमें भी है ना, we have two radii, since it's coming from this, which we call apogee period. तो जो two radii हमारे पास आएंगे. If a radii can also be written as in terms of showers, it can be written as if you multiply 1 plus E cos phi is equal to P, or is equal to P by 1 plus E cos phi. If cos of phi is equal to 0, maximum will be, it can also be P by 1 plus E. अब ये the radii can be maximum or radii can be minimum, because in case of ellipse we have two radii. If we have two radii, so for one of the radii, for minimum it can be. So for minimum radius A equals 1 minus E. for maximum rating is P by 1 minus 1 minus P अगर आएगा ये just इसको आप ऊपर कीजिएगा है ना ये इसको आप ऊपर कीजिएगा ये 1 minus P minus आएगा फिर minus minus plus हो जाएगा so further we can write this radian in terms of R minimum and R maximum depending upon the value of eccentricity. What's that value is there? अब ये हमारे पास ये knowledge है. So what we require this knowledge for? We require basically for calculating the orbits around in the centrally field. So we'll take recourse of in your earlier classes. जब आप कैपिलर्स लॉ पढ़ते हैं ना we straight away take to the definition equal areas है ना aerial velocity is constant है ना एक 1/2 or dot ठीक है. So if you want to write the same thing in terms of what we are doing, so we will just take for example equation 14.3 में हमने कहा था m जो बराबर है m is m f dot where f dot is the sectorial velocity है ना. आप कहते हैं ना ये जैसे if you remember ऐसे हम ये sectorial equal area that sectorial velocity is constant. So but if you write m in terms of you have written previously m can be written like this. If you write it this way then or so it also means m is equal to 2mf df by dt. इसको यहाँ लिखिए आप dt is equal to 2m f. So integrate it again both sides. So it will be t times m into 2mf. So again we can write Tm in terms of this area. अब ये जो time period है हमारे पास, so we are going to get to the sorry so again so from this we are going to get our time period of the which will come out to get we are going to substitute our value of if you remember हमने कहा था p को हमने ऐसे डिफाइन किया m square by m r. So we are going to substitute the value of m in terms of this p alpha by m. Okay, if you substitute it here value of m in terms of this we get time period हमारे पास आएगा and again and जो f is basically equal to pi a b. Pi a b means what? इससे area ना जैसे area नॉर्मली हम क्या कहते हैं 1/2 into base into 1/2 into length into this into height. ऐसे area तो ट्रायंगल करते हैं. अब यहाँ area है क्या? It's between a and b. So area of this patch is basically pi a b. And you can check it out actually. So it's a problem geometry. So हमारे पास time period है and our how we have seen this is area velocity and we have defined m in terms of this angular momentum. M in terms of if you remember m को हमने define किया था in terms of यहाँ पर m was defined m r square 5. Okay, so we can define time period and this information we can find. इसको आप थोड़ा सा simplify करो आप at your place, so it will take the form of this m/2. So we have found time period जो your earlier class में पढ़ते हैं time period is proportional to square root of the period and cube of the linear dimension of the orbit. ये पढ़ रहे थे ना Kepler's law. Kepler's law था ना ये this time period is proportional to square of this and cube of. So you have verified the same thing here also, but we have done the same thing by some another method. From our knowledge of how study ellipse, parabola, hyperbola, and how we have parameterized total energy of the system. ठीक है? And उस E को हमने E के साथ डिफाइन किया, इसेंट्रिसिटी के साथ रिलेट किया, and doing all these algebra and this putting these you could arrive at your job, previous understanding of the life process. ठीक है? So now this is for ellipse. So we can do the same exercise for parabola example also, as well as hyperbola. In real physical system, what will they correspond? They will correspond to what? They will correspond to, for example, अगर potential है charge particle, some particle is coming from infinity, it's coming towards the field. So it will be minus 1 alpha by r. Yeah? But if the charge is repelling it, it's going from this thing. इसका राशि कोड मुझे पढ़ते हैं. Elementary particle comes, so it's going to parabolic motion आएगी ना. So basically double charge is being repelled by nuclear, negative repulsion आएगी. So हमारे पास ये आएगा माइनस में आएगा potential, will get plus alpha by r, है कि नहीं? This alpha was the reduced mass, for example. Depends upon problem to problem. Two body problem, three body. अब क्वेश्चन ये है कि so ellipse के लिए we had this understanding. We just did this expression. So we can do the same thing for hyperbolic motion also. So what is the suitable choice of potential? ठीक है? And what is the value of E if it's not less than 1? That corresponds to ellipse. If it is greater than 1, if it is this thing, for the case of hyperbola or for the case of parabola, which motions will it correspond to? Got the point? Okay, so this is the point we are going to discuss. And again, we are going to do it in terms of R max and R minimum. Maximum कब radius होता है, कब? And in terms of E को हमने define किया था as dissect schematic. One, it's a line which passes through one of the forces. Okay, in case of ellipse, there are two forces. One corresponding to this and other corresponding to this. So now the tables are turned. The tables are not turned. We are saying now the case goes to a potential which will correspond to hyperbolic motion rather than elliptical motions. Okay, so that's the point. And we are again going to use our maximum, where the radius will be maximum and where the radius will be minimum, depending upon जो भी हम जैसे हम फिगर डिफाइन करें. Again, or minimum is E by E plus 1, or it will be A into E minus 1. Or A is for semi-major axis, it's like this. For parabola, hyperbola, the equation will go like this. Semi-axis of hyperbola. Yet you have to convince yourself. Why should it come like this for hyperbola? So it will do all the algebra. So it will not come the same. A का value is here this. वहाँ पर था B by E minus 1. E square नहीं था. ठीक है? Why it comes E square here? You just convince yourself. But you should know the knowledge of coordinate geometry. Conics, from the knowledge of conics. But not in the way you have studied. X square by A square is formula. Okay? then you can see this difference. And if eccentricity is equal to 1, if E is equal to 0, E is equal to 1. If E is equal to 0. E is equal to 0 है तो E आएगा फिर 1 के बराबर. And the particle moves E is equal to this equation, R is equal to E by 1 plus E cos phi. If E is equal to 3, 0 है, so E. E is equal to 1, R is equal to 3 by 1 plus E cos phi is 1, E भी 1 है, तो क्या होगा? R is equal to R. So R minimum will be now ये आपने अब किया ये exercise. Now we are coming back to what we have done. We are coming to our basic equation. जो दो equations हमारे पास थी, equation. Write it here. दो इक्वेशन ऑफ मोशन, एक इन द फॉर्म ऑफ टी एंड दूसरा इन द फॉर्म ऑफ फाइव. टी वाली इक्वेशन हमारी थी ये. मगर आपको समझ आ रहा है व्हाट वी आर बेसिकली डूइंग? श्रवण, so we know these two equations, T and 5. Now what we are doing basically? जरा आप इक्वेशन ऑफ मोशन करते हैं ना, 5 मिनट के बाद कहाँ पार्टिकल पहुँचे? हमने अक्सर we have a lot of problems. A particle is moving at this thing. We are applying a force of 5 Newton. We calculate the particle where its trajectory, where it lands after 5 minutes, है ना? At 6 minutes. अब यहाँ पार्टिकल नहीं मूव कर रहा है. Particle is moving in central rotation. And we have two parameters, T and 5. These are two different equations we have solved. So we have to find 5 को find करना है and T को find करना है. And depends upon other C है ना, other E, U, this. But if you remember E है ना, E को हमने ऐसे define किया, हमने उसको eccentricity के साथ relate किया. अगर value of E came out to be greater than 1, less than 1, so it corresponds to different E's. E less than 1, greater than 1, 0, and 1. So those will give us the value of the particles on the ellipse, hyperbolic motion and parabolic motion. In terms of E में भी जो है ना, वो हमने कहा था minus alpha by r. अगर alpha by plus minus आएगा तो उससे hyperbolic motion आ सकती है या उसमें further ये there are some things. So now we are going to solve these equations. हम अपने equation of motion जो कि हमारे points and these two equations को use करके now we are going to solve this differential equation. ठीक है? अब तक जो हम कर रहे थे stage set, what we are going to do. Now we are going to use solve these two differential equations in terms of r and phi. Relation of r and phi. Relation of r and phi. R is the trajectory, है ना? Of the particle to move कर रहा है r radius, and phi is the angle. So phi always varies monotonically with respect to time. इसका मतलब क्या है? It varies continuously. 5 2 minus 5 1 5 1. है ना, it varies. At every point angular momentum है ना phi वैल्यू करता है, जब डायरेक्शन चेंज होती है कंटिन्यूसली वैसे चेंज होता है. लीनियर वेलोसिटी में हम कहते हैं कांस्टेंट लीनियर वेलोसिटी. Acceleration we define two ways. Either there is change of velocity or change of direction. Both will correspond to acceleration. So here ये मौजूद and phi dot never change. It's phi change. So phi dot never change. Now, एक तो ये है हमारे पास, and जो U effect, if you remember, we can define U effect.
So angular acceleration.
Sorry. Now I just remember this picture. So अब T है phi. So now what we are going to do? We are going to so with A and E given. So our from the book with A and E given by equation 15.6 and 15.4. 15.4 15.4 एक तो ये हमारे पास बिंदु स्टार्ट हमने ऐसे किया था, डिफाइन E को ऐसे डिफाइन किया था एंड T को हमने ऐसे डिफाइन किया था. So E will depend upon E. We can write this integral. आप यहाँ पर आप सब्स्टिट्यूट करो इस इंटीग्रल में थोड़ा सा it will take some work, rough work. Since we don't have time in class, so you do it at your place. अब यहाँ ना E को हम राइट करेंगे in terms of है ना, it will be E square. अगर आप इसको करोगे इसको स्क्वायर E square is equal to 1 plus 2 M square by M alpha square. Yeah, E square minus 1 into M alpha square by M square equal to E. है ना? इस E को आप सब्स्टिट्यूट करते हैं, आपको यहाँ पर कहाँ पर सब्स्टिट्यूट करना है? We have written E into the E and M. Okay. So what I'll straight away do this thing. तो and इस सब को सब्स्टिट्यूट करना है कहाँ पर? यहाँ पर भी करना है सब्स्टिट्यूट, यहाँ पर करना है. In the first case, T can be T will come out to be or plus M square minus 2M into T. So you are going to substitute this value of E here, and I'll write a simplified form which you as an exercise will do at your place. So it's again repeating, ये है ना, you have not to accept things on the face value. The book has said you go from this to this, unless and until you verify it yourself. This means your work is not, you get tested. You verify it, you have थोड़ा सा substitute, you do it out of page, and you can write it like this.
So it's a morning. Just a morning.
This is mod E. Now you are going to do it in a simple way. कोई भी इंटीग्रेशन by substitution करेंगे. ठीक है. What we have done is that R minus A को हम in terms of we are going to write it in terms of minus A into cos theta. ठीक है. Denominator R minus A. इसको एक साइड होगा R minus A आएगा, ये बाहर आएगा, डिनोमिनेटर में आएगा, एंड ऊपर आएगा dr r dr, उसके So बनाएगा a is zeta. So you can simplify it. It will come out as value of t will come out as again ये थोड़ा सा work. ये आएगा 1 minus denominator में cos ये आएगा. ये रूट आएगा कट जाएगा एक बार रूट पर आएगा it will be 1 minus e cos zeta d zeta. And again if you will integrate it एक बार आएगा zeta ये आएगा e sin zeta. It will come out to be this. Yeah, you see. Now what you are saying, time is measured in such a way that the constant is 0. We have found two parametric difference. इस तरह आप करते हैं ना in your earlier classes. आप what you write इस तरह आप करते हैं ना x is equal to r cos theta, y is equal to
Sin.
a trajectory in a circle for example. So you can write this point as r cos theta, r
Sin.
at every point. In the same way, we are going to do the same thing exercise in terms of, but here we have not theta, we have in terms of phi. In terms of phi. So x is equal to r cos phi and y is equal to r sin phi. Where x and y they are parallel to major and minor axis of ellipse. Major and minor axis of. So again, this is simplification. We are again writing this in terms of phi, in terms of these or max or further capacity. And further, if we are going to write it this equation 15.5 and 10. 15.10 भी होगी this equation and 15.5 है हाँ 15.8 तो ये वाली equation ये हमारी equation तो आपने we wrote it in terms of this. Further आप लोग simplify this equation and this equation को हम further see it. So again इसमें आप थोड़ा सा just try to relate these two equations. थोड़ा सा और algebra it's not, it's bit tedious only. Okay. Otherwise it's as simple as that. Once you do it, so in terms of x usually, it will be, so I'll write straight away, x will come out to be, after doing the substitutions, x will come out to be cos of zeta minus e and y will be equal to, so हमने at the end क्या निकाला शब्द? So we have found the trajectory of the particle along x direction and along y direction in terms of eccentricities e and this zeta. अब zeta को हमने कैसे define किया? Those came out to be once हमने zeta को in terms of r and a define किया. R is the radian, A is the A max and A is the corresponding to ellipse का area. एक तो A है, एक B. ठीक है? So you have seen equation in terms of x. अब वो ये जैसे आप कहते हैं ना equation of ellipse x square by a square plus y square by b square is equal to 1. वहाँ करते थे a square b square हम करते थे e square minus 1 into a square. अब यहाँ भी हमें adjacent x निकाला y निकाला. But only one thing is जो हम यहाँ जो zeta है ना zeta, cos of zeta is written in terms of r and a. It can correspond to r max and r minimum. So we have got the trajectory of the particles moving, having energy, some energy, and उसकी elliptical motion या इसकी parabolic motion कैसे आएगी. अब ये है, now this is for elliptical motion. The same exercise can be done for the, I only state it in the book, but coordinates different. For hyperbolic orbits के लिए cos का फंक्शन होता है ऐसे, और ऐसे जाना चाहिए. अब इसमें थोड़ा सा मान दीजिए. X will come out to be. This is already solved in terms of X and Y. Last one. ये तो पहले वाली थी यहाँ पर. और the last one हमारे पास X. Y will come out to be. अब से इसमें if it's hyperbolic motion, only one difference is when we define U effective, तो वहाँ हमने ऐसे डिफाइन किया था ना, अल्फा बाय आर प्लस एम स्क्वायर बाय its particle is moving away. When you do particle को आप फील्ड से बाहर से आ रहा है तो आपको काम नहीं करना पड़ेगा. If you are moving away from the field, you have to do some work. If something is coming to the field, तो इससे माइनस प्लस का फैक्टर आएगा. ये सब इलिप्टिकल मोशन के आउट टू बी सेम. जब हमारे पास ये हाइपरबोलिक या पैराबोलिक मोशन आ रही थी ऐसे जैसे मैंने कहा था रास्ता को जैसे, ठीक है, इट विल कम आउट टू बी ये प्लस आएगा, माइनस अपना आएगा, माइनस माइनस आएगा प्लस. तो पोटेंशियल का फॉर्म आएगा ऐसे. It will not be minus alpha by r. It will be a minus minus हो जाएगा. But this is the only relativity. This is the variation. Variation is the problem. And जो हमारे पास ये p by r था, p by r is equal to p by 1 plus e cos phi. यहाँ पर हमारे पास आएगा P by R हम कह रहे थे इसको कर दो 1 plus e cos phi. तो यहाँ प्लस 1 नहीं आएगा, यहाँ माइनस 1 आएगा because of the change of sign potential. So again, you are going to do the same thing, time dependence in terms of parametric equation for R min max and R min, and do the same exercise whatever you are going to do for this thing in terms of 1, 2, at the end you will get the equation. एक पॉइंट पे कहूँगा तो मैं स्टॉप. We can conclude this section, last one. Conclude this. To conclude this section, we should there is an integral. There is an integral of motion which exists in only u is equal to alpha by r. ये कह रहा है इसी के लिए it's only true for this integral. तो इसका argumentation क्या? What the argumentation which is there? So it's easier to see by direct calculation of the quantity. So ये कह रहा है कि this will be constant only for this field, either sign of. So it's easier to wait for this calculation. अगर आप both sides को मल्टीप्लाई करोगे फॉर टोटल टाइम डेरिवेटिव, यू जस्ट हैव अ टोटल टाइम डेरिवेटिव सर, यू डॉट यहाँ पे लगाओगे, एक बार इसका टोटल टाइम, so you leave this argument, so like this what's correct so अगर आप इसका टोटल टाइम डेरिवेटिव निकालेंगे ना इसका, so what is the count, इसका एक का टाइम डेरिवेटिव आएगा, you can also write it like this, v dot cross n प्लस यहाँ से दो टर्म्स आएंगे, एक डिनोमिनेटर में एक न्यूमरेटर, so you can also write it as डिनोमिनेटर का ये है एंड न्यूमरेटर का ये, क्योंकि एक बार ये आएगा alpha g by r, and the second term here is like this, v dot r by r, this is थोड़ा complicated तरीके से है, r कैंसिल हो जाएगी, r स्क्वायर आएगा, वापस r आएगा, अब v dot r की फॉर्म में और since m is equal to mr cross b, तो अगर m को आप सब्स्टिट्यूट करोगे r क्रॉस b के साथ यहाँ पर, तो we have 4 terms, up again if you put m b dot is equal to alpha r by r, you will see if you put m b dot m b dot alpha r m b dot with this, so this will cancel with this and this will cancel with this, so the argument here is that this will only constitute for us the integral of the motion, मोडुलो साइन ऑफ प्लस एंड माइनस, तो उसके लिए ये क्या हो रहा है कि टोटल टाइम डेरिवेटिव लेता है, टोटल एनर्जी ऑफ द सिस्टम काइनेटिक, एंड इट विल कम आउट टू बी कांस्टेंट और इट विल कम आउट टू बी ए कंजर्वेटिव क्वांटिटी, जैसे कोई भी सिस्टम जो एनर्जी है ना, नेट एनर्जी इनसाइड ए सिस्टम विल बी, टाइम के साथ क्या होगा, एक पार्टिकल यहाँ से वहाँ जाएगा, दूसरा वहाँ से इधर जाएगा, ठीक है। आपकी कोई भी सिस्टम के लिए अगर ये है दिस कॉरस्पॉन्ड्स टू द पोटेंशियल 1/r, ये क्या है, इट्स ओनली कंजर्व्ड फॉर 1/r पोटेंशियल, दिस इज इट्स आर्गुमेंट व्हाट इज ट्राइंग टू से, इसको आप एक बार यू जस्ट ट्राई टू रीड इट, एंड द डायरेक्शन कंट्रोल इज अलोंग द मेजर एक्सिस फॉर द फोकस ऑफ द रे, सो यू नीड, इट्स नॉट क्लियर, यू जस्ट ट्राई टू स्टडी वंस ट्वाइस, ठीक है। So this is chapter 3. ठीक है, so अब हमारे ये है